Hello everyone, this is Sahil Singhania from Praise Sustainability. In this video, I present Module 3 of the ECOFACT educational kit that introduces the environmental assessment tools that we've developed as part of the project. I'll guide you through the lifecycle assessment and lifecycle costing methods. We will also explore the step-by-step processes involved in conducting an LCA and touch upon the computation of environmental impacts. So, life cycle assessment is a powerful method that guides us towards sustainable decision making in product development. It is a holistic approach that evaluates the environmental impacts of a product, process, or service throughout its entire life cycle, from raw material extraction to production, use, and ultimately disposal. LCA allows us to trace the intricate journey a product takes, shedding light on the resources it consumes, the emissions it generates, and the overall footprints it leaves behind. And this assessment is crucial because LCA equips us with the knowledge needed to make informed decisions that not only meet our present needs, but also reduce the potential future impacts on a larger scale. Now that we have looked into LCA, I introduce another powerful concept of lifecycle costing. LCC is like a financial roadmap of a product. It goes beyond the price tag and considers all the costs that come along with owning, operating, and even disposing a product. It helps us to add up all the costs of a product over the entire life cycle, and combined with LCA, it provides a comprehensive framework for making informed decisions that balance financial considerations as well as the environmental impacts. Now, understanding life cycle assessment involves a few key steps. First, goal and scope definition that includes setting up the purpose and the boundaries of the environmental study. Life cycle inventory analysis that includes gathering data on resources used and the emissions at every product stage, creating a comprehensive inventory. Lifecycle assessment that computes the contribution of this inventory towards the chosen environmental impact categories, which we will come to in the next slide. And finally, the interpretation that provides meaningful insights. Impact categories in lifecycle assessment, as briefly mentioned in the previous slide, represent specific environmental concerns or areas of impact associated with the lifecycle of a product, process, or service. They used to systematically evaluate and quantify the potential impacts on the environment. Thank you. Hello everyone, this is Sahil Singhania from Praise Sustainability. In this video today, I present a demonstration in reference to the Module 3 of the ECOFACT educational kit that introduces the environmental assessment tools that we've developed as part of the project. Previously, we covered the basics of life cycle assessment and life cycle costing methods, the two very crucial methods that help us in quantifying environmental and financial impacts of a product throughout its life cycle. Now in this video, I present a hypothetical example of a factory setup that explains LCA and LCC modeling in CMAPRO software. Let's examine a factory that manufactures two components utilizing a diverse range of inputs. These components are then assembled into a final product. And the diagram here illustrates the system boundary and the scope of our LCA study, focusing specifically on cradle to gate scenario. This means that we're considering only the raw materials and manufacturing stages until the final product is ready to leave the factory floor. Now, focusing on the goal and scope of our lifecycle assessment, our objective is to monitor the lifecycle impact per unit and evaluate it for informed decision making. We choose one final product as our functional unit, keeping our system boundary from cradle to gate. That means we're accounting for raw material extraction, manufacturing, and waste management, but excluding the downstream transportation, product use, or end-of-life considerations. Now, for the next step, we'll identify our data requirements, gathering primary data from the factory and supplementing it with secondary data from databases like EcoInvent. This lifecycle inventory will serve as a foundation to build a comprehensive model in CMAPRO. Moving forward, in the phase of creating lifecycle assessment model for our factory processes, Once we have gathered the necessary data from the factory, we construct a detailed lifecycle inventory. This model captures the entire production journey, focusing on one final product emerging from the assembly process. For example, the production of the component 1 requires 10 megajoules of thermal energy. The next step is to calculate the baseline results. By leveraging historical data, we can establish a baseline of our environmental impact. And this detailed analysis allows us to pinpoint significant contributors to the carbon footprint. Identifying these factors might prompt adjustments to our model or lead us to seek alternative data for more actual representation. Now, shifting our focus to the practical side of things, in CIMA-Pro, we create datasets for every process and compartment. These datasets are the building blocks of our assessment, pieced together using the inventory. We tap into external environmental databases to ensure that our data is comprehensive and up-to-date. So, similar to assembling a detailed puzzle, each dataset contributes a crucial piece to the bigger picture of our environmental impact. To order the impact assessment phase in CIMA-Pro, it computes the lifecycle inventory. It then categorizes the impacts based on various impact categories, helping us to understand the broader environmental picture. CIMA-Pro just doesn't give us raw data, but it translates it into multiple formats, offering us different perspectives and meaningful insights. Now let's apply the same procedure to evaluate the life cycle costing of manufacturing a new product. We have the flexibility to set additional parameters in CIMA-Pro, capturing material costs, energy expenses, waste management costs, or any other relevant cost elements. Now, calculating the life cycle cost mirrors the approach that we took for life cycle impact assessment. It's a similar journey, ensuring a comprehensive understanding of both the financial and environmental impact of a product's life cycle. Thank you very much.